Okay, in this video, we look into an example on how we can calculate the value of the centripetal force given in your textbook. You may turn your textbook into page 90 and look at this as this question. Okay, example number 1. Okay, question or example number 1. So given there, shows a hammer, thrower, athlete swinging an iron. So let's take out the information first. So it's the diagram is already given there. Okay, athlete swinging an iron ball in a horizontal circle before releasing it. What is the centripetal force? So the question asks for centripetal force. What is the centripetal force that acts on the iron ball when the iron ball is moving at speed? So given is speed equals to 20 meter per second. Okay, and then given a diagram. So this person holding the hammer. Okay, a radius equals to 1.8, and mass is given as 7.2 kilogram, 1.8 meter. Okay, so now we have our information. Okay, let's change my screen first to this one. Okay, so this is the diagram given. So what can we see here? Okay, this hammer, it will rotating or it will revolving around this direction. Okay, so if we look from above, let's say this is the person and it is holding the hammer at radius equals to 1.8 meter. Okay, let's make it prettier. Okay, so this is the hammer, radius equals to 1.8 meter. Okay, 1.8 meter. Hammer, this is person. So the mass is equals to 6.2 kilogram. Okay, and then what will happen? It will move in a circular path. Okay, it will move or it will rotate either clockwise or anti-clockwise, but of course it will move on a circular path at constant speed. Okay, at constant speed. Okay, constant speed, which is equals to, okay, the speed is equals to 20 meter per second. So here it is moving in this direction, 20 meter per second. Here 20 meter per second. Or on each point, on every point on this path is equals to 20 meter per second. So that is the story of this case. So what can we investigate there? So this, since this object is moving, so it is moving in circular path. Okay, circular path. So since it is moving in circular path and what else? Okay, moving in circular path, direction. Okay, so that's mean the direction keep changing. Okay, keep changing. Since it is moving in circular path, so we can say that the direction keep changing, although, okay, though the speed constant. Okay, though the speed is constant, so we can see that it is as a accelerating. Okay, so for an object, accelerating object. Okay, accelerating object must be influenced. It must be influenced by force. Okay, by force. Remember what you had learned in your form 2. Okay, force is needed to change the direction or to change the velocity. Okay, of course the velocity, because velocity also depends on the direction. So there must be a force that acting on this object. Okay, so for circular motion, okay, for circular motion, the only force that will the only force that we have here is the tension. Okay, this is the tension between the hammer and this person in the connecting thread or the connecting wire that we have here. Okay, so the tension here is equals to the force. Okay, equals to the force. Okay, remember tension also is type of force. Okay, so there must be a force. So there must be force behind this motion, this kind of motion, which we call as centripetal force. Force. Okay. So based on this, since we know that the force that acting on this object is the centripetal force, so the formula that we can use, okay, so the formula that we can use, so F equals to mv square over r. V is the speed, okay, V is the speed, r is the radius or the distance between object and center, m is the mass of this object. Okay, so don't forget, write your formula first, okay, to make sure that you're familiar with the formula. So write formula first and then substituting, okay, substitute all the values. So we have mass, which is equals to 7.2 kilogram, v square, so v square, so it is 20 meter per second minus 1 divided by the radius. So radius is equals to 1.8 meter. Okay, 1.8 meter. So what we get here, okay, take out your calculator. So what is my calculator? Okay, 7.2, 7.2, okay, 7.2. Okay, I forgot the square here, so should be square. Okay. Should be square. 7.2 times 20 square. Okay, 20 square divide by 1.8, 1.8 equals to 1600. Okay, 1600. What about the unit? Okay, what about the unit? So since it is force, you can put it as Newton, but make sure before you put Newton, mass must be in kilogram, length must be in meter, time must be in second. Okay, so these three must be equivalent. Okay, must be equivalent. Or you may check your unit here. So F mv square over r. Okay, like we use different color here. Mv square over r. So the mass for mass, the unit for mass is kilogram. Unit for speed, meter per second minus 1 square divide by radius, it is m. Okay, it is m, meter. So kilogram meter square, so we will get meter square. Second minus 1, okay, learn what you just use what you had learned in your maths. Let's say we have x minus 1 square, so we will get x minus 1 times 2, which is x minus 2, x minus 2. So here s minus 1 times 2, so we will get s minus 2 divided by m. And then meter cancel out, kg stay there, meter left, 1 is left, okay, s minus 2. So it is equivalent to Newton. Okay, so that is how we can calculate the centripetal force. Okay, the centripetal force given in this example in your textbook. Okay, that's all for this session. Thank you.